All right, so next we're going to take a look at simplifying these radical expressions when there's also variables involved. So we're still going to follow those same rules that we followed from working with just the numbers, but we also can deal with variables the same way. Keep in mind that a radical can be simplified if the radicand contains a perfect square. Now with variables, that could also mean that it's the same factor appearing twice. In this example, we have the square root of 9xy squared. What I'm going to do is I'm going to write this out as a list of factors. So I know that 9 is 3 times 3, and I know x is x, and I know that y squared is just y times y. So I'm basically just expanding the 9xy squared. When I do this, I see that I have the same factor appears twice a couple of times. I have 3 times 3, so that's the same factor of 3 appearing twice. And then I also have that again with the y's. Now I only have one x, so the x does not appear twice. So that does not represent a perfect square. Well, I know that 3 times 3 is 9, and the square root of 9 is 3. The y times y would represent y squared, but the square root of y times y is y. So I was able to simplify two things, and I'm still left with the x inside the radicand. So that stays underneath the square root symbol as the square root of x. The 3's simplified out because there were two 3's. The y's also simplified out because there were two y's. The square root of y squared is just y, and the square root of 9 was just 3. So my final answer here would be to just kind of put the 3 times y together, is 3y, and the square root of x at the end. Let's take a look at the next one. 8a cubed is underneath the square root. So we have, let's see, the square root of 8a cubed. Let's start by kind of breaking that up a little bit. 8 I know is 2 times 2 times 2 in its simplest form. And then we have a cubed is a times a times a. So 2 times 2 times 2 times a times a times a is another way to write 8a to the third power. Now when we do that, we see that we have factors that repeat or appear at least twice. And remember, with perfect squares, another definition of perfect squares is having that same factor that appears twice, whether it's a number or a variable. So if I have 2 of the same thing, I can count that as a perfect square, which means it can be simplified out of the radicand. So 2 times 2 is 4. So basically, the square root of 4 is 2. A times a is a squared. So the square root of a squared is a. And then I'm left with a 2 and an a still underneath the radical symbol. So it's a square root of 2a left over yet. So my final answer ends up being 2a times the square root of 2a. Our third example, we have the square root of 28 x to the fifth power y squared. Now we're starting to get into some bigger numbers like the number 28. So instead of trying to break it down into, well, it's called a prime factorization, like 2 times 2 times, I don't even know what this one is, 2 times 2 times 7, I think. The other thing you could do is you could try to figure out what perfect square can I divide out of 28, much like we did in the first video for this lesson. So if we go to Schoology, you should find that perfect square multiplication chart that looks like this. And it's actually, I'll show you where it's at. It's in the Unit 7 Day 1 folder where you found this video. It's just called Perfect Squares Chart. It's just an image. So if you click on that, it'll open up this image. So we're trying to find 28 and try to figure out what two numbers multiply up to 28 where one of those numbers, one factor, represents a perfect square. So I'm looking for 28. I know that it can't be these numbers on the top, these perfect squares that are larger than 28. So I'm going to start at 25, and I don't see 28 there. Under the 16 column, I don't see 28 there. Under the 9 column, nope, no 28. How about under the 4 column? There it is. 4 multiplied by 7 is 28. And since 4 is a perfect square, that's going to help us simplify this radical. So what I'm going to do is I'm actually going to rewrite this using 4 times 7 and then all of the x's, so x to the 5th power, and then also the y squared. So that was all inside the radicand. So when I simplify, I do see that I have some factors appearing twice. For example, I have 2 x's, I have another 2 x's, and I have 2 y's. But then I also have a perfect square. It's not that the 4 appears twice, but it's a perfect square because the square root of 4 is exactly 2. I could have just as easily written that as 2 times 2 times 7 with all of the x's and the y's. So when I go to simplify that, anything that I have circled represents a perfect square and can be simplified out of the radical. So I have the square root of 4, which is 2. I had one pair of x's. I had another pair of x's. And I had a pair of y's that simplify out. 2 times x times x times y. And then I still had a 7 and the other x left over in the radicand. So to put this all together, I multiply those things out front. 2 times x times y becomes 2x squared y times the square root of 7x. So I just had to kind of combine the two x's together using an exponent. And that would be the simplified form for our third example. All right, last one. This one's a little bit different because it has a 3 at the beginning, right out there, but I'll show you how to deal with that. We're basically going to start by simplifying this radical, simplify what we have, and then whatever we get at the end, multiply by 3. Okay, so whatever that coefficient is, we multiply by 3 and kind of incorporate that. So let's start with this radical. We had 12 a to the 4th power b to the 3rd power. I want to try to figure out how to get 12 using perfect squares. So I can go back to my chart, and I see that 12 is going to be between 9 and 16, so that's my starting point. I'm looking for where does 12 appear underneath the perfect square. Oh, there it is. 4 times 3 is 12. 4 is a perfect square. So that's going to help me simplify. Next, I have all my variables, a times a times a times a, and then b cubed is b times b times b. And remember our two rules over there on the left for how we can simplify anything that's in the radicand. I can look for perfect squares. Well, I know that 4 is a perfect square. The square root of 4 is 2. It gets multiplied out front where that 3 was. 3 is not a perfect square. This 3 here. And then everything else, I guess I want to look for the same factor appearing twice to represent a perfect square. So I have a times a. So the square root of that is just a. I have a times a again, which represents a squared, and the square root of a squared is another a. And then I have a b times b. And the square root of b times b is b. And then what's left over is I had the 3 and the b still in that radicand. So now I've got everything written out. I just need to do a little simplifying. By kind of multiplying all this together. Let's see, 3 times 2 is 6. A times a is a squared. And the b. And then the square root of 3b. So 6 times a squared times b times the square root of 3b is the simplified form of that expression.